All right, so this is on section 5.8, which is on confidence intervals for the variance and standard deviation. So before we do that, let's first introduce chi-square distribution. So it takes two parameters, nu and alpha. Same with t, so nu stands for degrees of freedom. So it's the same as the student's t distribution. For each degree of freedom, we have a table. So for each degree of freedom here, and for some values of alpha, we have the values of chi-square. Here are two things to note. Chi-square is always positive. Notice that it's always to the right of 0, so it's always positive. And the second thing is it's not symmetric. So if you look at the curve here, it is skewed to the right, so it's not symmetric. And this actually matters because for z, all we need is to find plus minus z sub alpha over 2. For t, all we need is to find plus minus t sub n minus 1 comma alpha over 2. But for chi-square, because it's not symmetric, so we need two values. One being chi-square with degree of freedom n minus 1 comma alpha over 2. But we also need a value of chi-square with degree of freedom n minus 1 and 1 minus alpha over 2. That's why for alpha equal to 0.025, the value for alpha equal to 0.975 is also provided. So let's do an example. Suppose n is 5 and we want to find 95% confidence level. Then the relevant chi-square values are chi-square with degree of freedom 5 minus 1, so it's 4. And because it's 95%, so 0.025, and chi-square 4 comma 0.975. So we need these two values. So we search for row 4 and 0.975 and 0.025. So these two are the values we need. So the first one is 11.143 and the second one is 0.484. Alright, so now we know how to use the chi-square table. Let's learn how to construct confidence interval. So suppose we have a sample, and then it's the same with student's t distribution. We have to assume this sample is from a normal distribution. Otherwise, it cannot be used. So this is an important assumption. So suppose we have a sample from a normal distribution with population, standard deviation, with population, standard deviation, sigma. And that S be the sample, usually Sx, be the sample variance or standard deviation. Then the quantity n minus 1 times x squared over sigma squared has the chi-square distribution with degree of freedom n minus 1. So that means if we want to construct a level 100 times 1 minus alpha confidence interval, this quantity is going to be between chi-square sub n minus 1 comma alpha. The left side is n minus 1 comma 1 minus alpha over 2. The right side is chi-square degree of freedom n minus 1 and alpha over 2. And if we do some algebra, move things around, we get sigma square is between n minus 1 times s squared over chi-square with degree of freedom n minus 1, 1 minus alpha over 2. Similar on the other side. Chi-square n minus 1 comma alpha over 2. So the level 100 times 1 minus alpha percent confidence interval is given by this interval, which these two terms copied over. S squared, chi-squared, n minus 1 comma 1 minus alpha over 2. And this is the level 100 times 1 alpha percent confidence interval for sigma square. And if we want the confidence interval for sigma, all we need is to take the square root on both sides. So it's going to be pretty much the same thing. With the square root on both sides. So this is the formula for confidence interval for variances and for standard deviation. All right, so let's do an example. So let's first by making this assumption. So assume human IQs are normally distributed. So for chi-square to work, we have to assume our sample comes from a normal distribution. Now, let's sample 5 humans. And their IQs are 115, 112, 106, 101, and 95. So we can calculate the sample standard deviation. Using calculator, sample standard deviation is equal to 8.1. And to find the confidence interval for sigma, we need to find the chi-square values. So for 95% confidence interval for sigma, we need the value of chi-square 5 minus 1 degree of freedom, comma 0.025, and same thing but for 0.975. We already found these values in page 1, so you can look back. First one is 11.143, and the second one is 0.484. Now we can construct a 95% confidence interval for sigma. So it's a giant square root with n minus 1, so it's 5 minus 1, and then times s squared, which is 8.1 squared. And at the bottom, we have the two chi values. So the left one is going to be 11.143, and the right one is going to be 0.484. If we plug in calculator, this is equal to 4.203, comma 20.1661. So this is our 95% confidence interval for sigma. And here's a side note. This interval actually catches the true value of sigma, which is 15. 15 is between this interval. All right, so that's it for 5.8.